very important topic in real analysis, that is power series and the radius of convergence. Today we will discuss power series and radius of convergence and Csir mathematics problem solving session. Here we will solve uh, all problems in Csir net examination that involves radius of convergence and power series. Okay, so first we will discuss a few theory part. So the prerequisite for this lecture is sequence of numbers, convergence of sequence and series, ratio test and root test. If you know this, we can easily complete this lecture, and you can easily solve problems by using power series or radius of convergence, some formulas. Okay, now first we will define what is power series. So definition: a power series about A is any series that can be written in the form sigma n equal to 0 to infinity a n x minus a all power n. So here a sigma a n x minus a all power n, where uh, so this x belongs to R. Now we want to, this is a series, right? So we want to check for what values of x the series converges. So for that we will define a new term or new number called radius of convergence of a power series. It is a number R such that the power series will converge for mod x minus a less than R, and a power series will diverge for mod x minus a greater than R, and it may converge or may not converge for mod x minus a less than R. So if this is the number radius of convergence such that this power series converges for all x such that mod x minus a less than R and x minus a greater than R, the series diverges. Okay, so this is important. So for if you take any x in the interval x minus a, x plus a, sorry, x in the interval r minus a, r plus a, then if you take any x, then this series will be convergent. Now okay, now we will discuss, we want to find out what is R. We want to derive a formula for radius of convergence. For that, we know that ratio test. A series sigma n equal to 0 to infinity Cn of non-zero terms, and let L equal to limit n tends to infinity Cn plus 1 divided by Cn, then if L less than 1, the series is convergent or absolutely convergent, or if L greater than 1, then the series is divergent. So when is series converges? If L less than 1 and series diverges for L greater than 1, and we cannot say anything when L equal to 1. Okay. Now what is root test? Root test a series sigma n equal to 0 to infinity Cn x minus a all power n of non-zero terms, and let L equal to limit n tends to infinity Cn all raised to 1 by n. If L less than 1, the series is convergent, and L greater than 1, series is divergent. Or sometimes we will take this is enough, limit sup is enough. Sometimes we cannot find the limit, then we will take L is limit sup, or there also limit supremum. Okay, so limit sup. So if limit sup L equal to limit sup less than 1, then the series is convergent. Now we want to find out what is derive radius of convergence. So let Cn, or let radius of series is 0 to infinity an x minus a all power n. Now we want to find out for what r this series is convergent, or for what r, that is mod x minus a less than r. For this, the series is convergent. So we know that by ratio test, what we can take, we have ratio test. I'm taking Cn is equal to an x minus a all power n, which implies now we have L equal to limits sup, or Cn plus 1 divided by Cn, which is equal to limit supremum of what is an plus 1. So an plus 1 x minus a all power n plus 1 divided by, I am taking modulus, so that an x minus a all power, and this will converge when L less than 1. So converges if L less than 1. Now what is this? Limit supremum of an plus 1 into x minus a all power n plus 1, and this will get cancelled. So x minus a divided by a. This is less than 1. So which implies mod x minus a you can take outside, limit supremum of mod an plus 1 divided by an less than 1. So when is a series convergent? Series is convergent if mod x minus a less than 1 by limit supremum of mod an plus 1 by a, which is equal to r. So r is equal to, you can take reciprocal of this is limit supremum of n tends to infinity an divided by an plus 1. So this is the derivation of radius of convergence. So radius of convergence is limit supremum mod an, or an divided by an plus 1. Similarly, if we derive from ratio root test, then we will get r is equal to limit n tends to infinity, or limit supremum of n tends to infinity, or 1 by r is equal to limit n tends to infinity an all raised to 1 by n, which implies r is equal to limit n tends to infinity, or limit so or 1 by limit supremum of an all raised to 1 by n. So we got radius of convergence. Radius of convergence formula. So we get two formulas. So, so we get two formulas. One is R is equal to limit supremum of an divided by an plus 1, and another one is R equal to 1 by limit supremum of an all raised to 1 by n. Okay, now we will solve CSIR net problems by using this. So this is CSIR June 2013 problem. The problem is uh, the power series sigma n equal to 0 to infinity 2 plus minus 1 all power n divided by 3 power n x raised to n converges. So we want to converge, we want to check for what values of x this is convergent. The options are given. Now it's enough to find the radius of convergence of this. So here an is given 2 plus minus 1 all power n all raised to 1 by n divided by 3 power n. So this can be written as an is equal to 2 plus minus 1 power n divided by 3 all raised to n. Now here there is raised to n, so I am taking radius of convergence formula 1 by equal to n tends to infinity limit supremum of an all raised to 1 by n, which implies 1 by r is equal to limit n tends to infinity or limit supremum of 2 plus or minus 1 by n all raised to 1 by n get cancelled. So this is something, this sequence is something like you will get when n is even, that is n equal to 0, 1, n is odd 1 by 3, 1, 1 by 3, 1, 1 by 3, etc. So what is supremum? Limit sup is 1. So 1 by r equal to 1. Therefore r is equal to 1. Therefore we get it converges for mod x minus, okay, there is a x mod x less than 1. Now we don't know what happens at the endpoint, so we can cancel out these two options. So now we have to check whether it converges for when x equal to 1. Okay, if x equal to 1, if the series is convergent, then option 4 will be correct. So we have to check both. So if x equal to 1, then what will happen to our series? N equal to 0 to infinity 2 plus minus 1 power n all power n divided by 3 power n into 1. So this series is something like you will get 1 when n equal to 0, you will get 1 plus 1 plus n equal to 2, you will get n equal to 1, you will get 1 by 3 plus 1 plus 1 by 3 square plus etc. Now if you take n even, then what will happen? It has this is sequence of partial sum Sn. Then this sequence of partial sum, if S2n is equal to 1 plus etc. So the subsequence, this converges to infinity. So a subsequence of sequence of partial sum is divergent. So therefore the series is divergent when x equal to 1. Therefore this option is wrong. This is true. So So we get the answer. Now we will move on to the next problem. This is a problem in December 2016 problem, CSIR net problem. The radius of convergence of the power series is, this is the series. Now what I will take an is equal to, so here this is z raised to n square. So I am taking an equal to z raised to n square. Now I will use ratio test here, because here there is no n, here n square is there, therefore we cannot use that formula, because we derive formula for x minus a all power n. So what we will take, we will take ratio test. Limit n tends to infinity, z raised to n plus 1 all square divided by z. Okay, I will, what is ratio test? L equal to limit an plus 1 divided by an less than 1, then converges. So for what values converges? L less than 1, which implies L equal to limit n tends to infinity an. So here an is z power n. So z raised to n plus 1 all square divided by z raised to n square. So when it is convergent, less than, which implies limit n tends to infinity z raised to n plus 1, you can realize z raised to n square plus 2n plus 1 divided by z raised to n square. Okay. So here you can cancel out z raised to n square and z raised to n square. So you will get limit n tends to infinity z raised to 2n plus 1 less than 1. So this happens only when mod z less than 1. So what is the radius of convergence? So radius of convergence is mod z less than 1. So this is the answer. Now we will move on to the next problem. So in this problem, it is given that this is CSIR June 2016 problem. Given that p of x be any polynomial of degree greater than or equal to 2, then the radius of convergence of the power series. So we will take a trick. So we have, this is any polynomial. So I am taking p of n equal to n square. So its degree is 2. Now what will happen, this is equal to sigma n equal to 0 to infinity n square z raised to n. Now we will find the radius of convergence. So what is radius of convergence? We know that r equal to limit supremum of an divided by an plus 1. So this is equal to limit an n square divided by n plus 1 all square. So this is equal to, what is this? If you take a limit n square into 1 divided by, if you take n square outside, 1 plus 1 by n all square. So this and this get cancelled. So this you will get answer is 1. So this is true for 1. So these options are all false. So the correct answer is this. Now we will move to next problem. Next problem is CSIR June 2017 problem. So here given the power series f of x is equal to sigma n equal to 2 to infinity log n x raised to n. We have to find out the radius of convergence. So here given that an is equal to log n. Now We know that the formula is limit n tends to infinity, limit supremum of tends to infinity an divided by an plus 1. So this is equal to limit n tends to infinity log n divided by log n plus 1. Now, if you give the value infinity here, you will get infinity by infinity. So this is L'Hopital form. So we will apply L'Hopital rule. Then you will get this is equal to limit n tends to infinity 1 by n divided by derivative of log n 1 by n divided by 1 by n plus 1. This is equal to limit n tends to infinity n plus 1 divided by n. So this is equal to limit n tends to infinity. You can take n outside 1 plus 1 by n divided by n. You got n and n cancelled. Then the limit is 1. So what is radius of convergence? So we get radius of convergence is 1. Therefore, this option is correct. Now we will do the next problem. And this is the last problem I'm here discussing. So here, this is December 2018 problem. So every year there will be one question in radius of convergence. So let R denote the radius of convergence of the power series sigma k equal to 1 to infinity k x power k. The options are given r greater than 0 and the series is convergent on closed interval. R minus r greater than 0, the series is convergent at x equal to minus r but does not converges at x equal to r. Now r greater than 0 does not series does not converge outside minus r and r equal to 0. Now first we will find what is radius of convergence. So radius of convergence is limit supremum of an divided by an plus 1. So this is equal to here what is an? An is equal to or ak an equal to or ak equal to k. So I am here rewriting it as k. Then this is equal to limit supremum of ak k by k plus 1. So what is this limit? This is equal to 1. Therefore, the series convergent when mod x less than 1. That means it is always convergent at minus 1, 1. This is for sure. But what we don't know, whether it is convergent at 1 or minus 1. Now, if I check, put x equal to 1, then what will happen? Sigma k equal to 1 to infinity k. This is infinity. This is divergent. And what happens when x equal to minus 1? Sigma k equal to 1 to infinity k into minus 1 power k. This series is also divergent because this is unbounded series and this series has two subseries which converges to different limits. So this is not so only it converges on minus 1 1. So from the option this is wrong because r is minus r, it's not closed interval. When r greater than 0, here we have r is 1, it converges at a minus 1. That is also false. If r greater than 0, so 1, so 1 greater does not converges outside minus 1 1. That is for true. So this option is true. So this is false. So the only option true is. Thank you.